Imagine an object traveling toward us not from our solar system, but from another star entirely. That's what made 3I/Atlas so shocking. Fast, mysterious, and unpredictable, it raised a question scientists rarely face seriously. What if an interstellar object actually hit Earth? Today, we're breaking down exactly why 3I/Atlas was so unusual, how its alien origin changes the physics of impact, and what a collision with a visitor from another star would really mean for our planet. No doomsday exaggerations, just real science, unfolding in the most dramatic way the universe can deliver. When astronomers first spotted 3I/Atlas, they immediately realized this wasn't just another comet drifting lazily around the sun. Its trajectory was hyperbolic, meaning it wasn't bound to our solar system. It came from elsewhere, an interstellar traveler just passing through. That alone made it the third confirmed interstellar object ever detected, joining the select club with 1I/Oumuamua and 2I/Borisov. But what truly intrigued scientists was its behavior. Interstellar objects move fast, far faster than normal asteroids, because they carry the velocity of whatever alien gravitational system flung them out. 3I/Atlas was no exception, racing through space at speeds that could dramatically amplify the energy of any potential impact. Its brightness changes also suggested volatile rich material, possibly containing exotic ices or compounds formed in environments completely different from our own. Every such object is like a cosmic sample capsule, carrying chemistry from another planetary system. So when astronomers ran simulations and asked, what if something like this actually struck Earth? They weren't being dramatic, they were exploring a scenario with real scientific consequences. Now that we know what made 3I/Atlas unique, the next question is irresistible. What would actually happen if an interstellar object hit Earth? The biggest misconception about incoming space objects is that any interstellar visitor would automatically spell global destruction. In reality, the outcome depends on three factors: size, speed, and composition. And interstellar objects like 3I/Atlas only change one of those dramatically: speed. Because 3I/Atlas likely traveled at 50 to 80 km/s, even a medium-sized impactor would release far more energy than a typical asteroid. A 150-meter object at interstellar velocities could generate an explosion in the tens of thousands of megatons, far beyond any natural event in human history. On land, the impact would carve a multi-kilometer crater and flatten entire regions. Over the ocean, the shock would launch a megatsunami capable of crossing seas. But even at these extreme energies, this isn't a planet-ending scenario. Earth has endured far larger impacts in its geological past. An interstellar strike would be a civilization-level event, regionally devastating cities, reshaping coastlines, and disrupting climate for months or years, but humanity would continue. The most fascinating part is that the explosion itself might look different. Exotic ices or alien compounds vaporizing at high speed could create unusually bright plumes or unexpected chemical signatures. So the damage is one story, the information we'd gain is another entirely. The scientific excitement around 3I/Atlas isn't rooted in fear, it's an opportunity. Each interstellar object is a physical messenger from a completely different star system. It carries chemistry, structure, and materials that never formed here. Studying it offers clues about how other planetary systems evolve, what kinds of comets or asteroids orbit alien suns, and even how worlds across the Milky Way might form water, organics, or metals. If a small interstellar object actually entered the atmosphere or even struck Earth, scientists would gain access to material that cannot be collected in any other way. The vapor plume alone could reveal molecules never seen in our solar system. Shocked minerals and isotopes from such an event would tell us the temperature, pressure, and composition of environments far away from our sun. That's why astronomers push to detect these objects earlier and track them more precisely. Not because they expect danger, but because every one of them is a once-in-a-lifetime scientific opportunity. Interstellar visitors help refine our models of planetary defense, deepen our understanding of cosmic chemistry, and expand our picture of the universe in ways telescopes alone never could. 3I/Atlas wasn't just another comet, it was a cosmic outsider racing through our solar system with the power to change how we understand planetary defense and interstellar chemistry. A collision would be devastating regionally, but far from an extinction event. More importantly, it would offer scientists a priceless window into materials forged around another star. Interstellar objects like 3I/Atlas remind us that the universe is constantly sending messages across unimaginable distances. If you enjoyed diving into this mystery, don't forget to like, share, and subscribe for more deep space discoveries. The cosmos always has another surprise on the way.